For problem 13, it reads, the number of students participating in fall sports at a certain high school can be shown with the following matrix. So you have tennis, 25 students, soccer, 30 students, cross country, 50 students, and football, 80 students. The athletic director estimates the ratio of the number of sports awards that will be earned to the number of students participating with the following matrix. So tennis, it gives a ratio of 0.2. This means that 20% of students participating in tennis would win an award according to the estimate by the athletic director. That's what a ratio does. Soccer, 0.5, in other words, 50%. Cross country, 0.3, in other words, 30%. And football, 0.4, in other words, 40%. Now, you don't need to convert, but I'm explaining what these ratios stand for. Now, given these matrices, what is the athletic director's estimate for the number of sports awards that will be earned for these fall sports? So we have some choices here, and essentially what we need to know is, say, for the tennis, we have 25 students participating, and according to the matrix, the ratio of awards is 0.2, in other words, 20%. So the athletic director estimates that out of the 25 students, 20% of them will win an award. So essentially, you're multiplying 25 times 0.2. It's the same as 25 times, say, 20%. You just need to know that 20%, of course, in its decimal form is 0.2. So once you key in 25 times 0.2, you're going to get 5 for 5 students winning an award in tennis. You do the same for soccer. So you would do for soccer 30 times 0.5. Now, 30 times 0.5 or 50%, it means half of them will win, so that's 15 students for soccer. Then for cross country, you have 50 students participating, and its ratio is 0.3 or 30%. So 50 times 0.3 is equal to 15. And then finally, for football, we have a total of 80 players participating, and the athletic director thinks that 40% of them will win some sort of an award. So 80 times 0.4 is, of course, equal to 32. So we have 5, 15, 15, and 32 awards per sport. They want us to say how many will be earned for these fall sports, in other words, for all of them. So now we just need to add 5 plus 15 plus 15 plus 32. And if you do that, you get 63 and 62 and 5, which is 67. For problem 13, they're telling us the number of students participating in fall sports at a certain high school. So that's one of the tables. And then the other one is the ratio of the number of sports awards that will be earned to the number of students participating. It's also presented in the matrix. And so, for example, for the tennis, you have 25 students participating, and then the ratio matrix says that tennis is 0.2. What that's telling you is that essentially, out of every student, 1.2 will win in a tennis award. So the way to figure out the answers to each of these would be to first multiply tennis students, 25, times 0.2 for the ratio for that sport. You get 5. So that means 5 students out of the 25 students participating in tennis will win, because this ratio, which can be expressed or seen as a percentage, 20% of the students participating win awards in that sport. You do the same for the soccer. For soccer, there's a total of 30 students, and you multiply that times its award ratio, which is 0.5, 50%, so that's 15, half of them. So half of 30 is 15. Then you do the same for cross country. 50 students are participating in that sport, and its ratio is 0.3. That means 30%. So if we multiply times a ratio value of 0.3, we get 15 again. And then finally, for football, it has 80 students participating, and it says 0.4 as its ratio for awards. So you multiply 80 times 0.4. In other words, 40% of these students will win an award. 40% of 80 is, of course, 32. So now we have 5, 15, 15, and 32 as the awards that will be given. So you have to total those, add them. So it would be 32 plus 15 plus 15 and plus 5 for a total of 67 awards, which is choice D. For problem 14, reads the following. The following chart shows the current enrollment in all social studies classes, geography, U.S. history, world cultures, and government at Iron Mountain High School. So we have a chart here with course title, We have the section of each of those titles, the periods, and then the enrollment, the number of students enrolled. So for example, geography has two sections, section A and section B. Section A is period 1, section B is period 2, and then the enrollment is 23 students for section A at period 1, and 24 students for section B, period 2, and on for the other courses. Now the question is, what is the average number of students enrolled per section in U.S. history? So you go to the chart, U.S. history, and you notice that there are a total of 3 sections, A, B, and C. So you have 25 students in section A, plus 29 students in section B, plus 24 students in section C. Why am I adding? Well, because if they want the average, an average, as you know, is equal to the sum of, in this case, all the sections, so section A plus B plus C, and then dividing by the number of sections that we added, in other words, 3, and that'll give us the average. So adding 25 plus 29 plus 24, very easy on the calculator, shouldn't have any issues with that one. So you get a total of 78 students. Now we divide 78 by 3 to find the average in U.S. history. So 78 divided by 3 is equal to 26. So the correct answer is choice G, 26.
For problem 14, to find the average number of students enrolled per section in U.S. history, well, we need to understand that U.S. history has 3 sections based on the table A, B, and C. And each one of those sections has 25, 29, and 24 students respectively. So to find the average, you simply add all the students in each of those sections divided by the number of sections, which is 3. So you do 25 plus 29 plus 24 for a total of 78 students, and then divided by 3 for 3 sections, 1, 2, 3 sections, and you get the average of 26. Be careful with the TI that you don't make the mistake of doing, oh, it's easy, 25 plus 29 plus 24 divided by 3, and then you're entering the wrong thing if you do this because you're not using a parentheses for the sum. So remember the order of operations, PEMDAS, P for parentheses, none, E for exponents, none, M, D, multiply, divide, it'll divide first. So when you do this, you're going to get a different answer, 62, which is clearly not what you're looking for. And the reason why this is not the answer to the prompt is, again, because you didn't use parentheses. Look what happens when you use parentheses like this. Now the calculator is going to first do P for PEMDAS, parentheses, grouping symbols, so it'll add. It'll get 78, and then it'll divide by 3, which will be 26. 26.
For problem 15, we need to use the same chart as the one we used in problem 14. You can see it here. Problem 15 reads, the school wants to have all of the students enrolled in social studies classes read the same book at the same time so that the author of the book can speak to the students at an assembly. The school originally purchased 2 classroom sets of 30 books each. So we can write that there, set 1, and then set 2, 30 each. But now, one set is missing 3 books. So the set 1, say, would have 27 books available, while the other one is missing 5. That means that it'll only have 25 books available. For which of the following class periods, if any, are there not enough books available for each student to have 1 book? In other words, you're going to have students go into a classroom because you have these classroom sets for these books. We want to know if there's going to be an issue with any one of these classes. We wouldn't have enough books for everybody. So we have some choices here for each of the periods, and then there are enough books for each class period. So how do we tackle this? Well, if you think about it, you need to just take it in steps. First, how many periods do we have? Well, we have 1, 2, 2, 3, 4, 3, 4, 6. So we have period 1, period 2, period 3, period 4, and period 6. So let's analyze period 1. Period 1 has only one section, one class, geography, section A, with 23 students. So there's certainly, if we have 2 sets, one with 25, one with 27, clearly, even if they go into the classroom with the least number of books, the set 2 here, 23 students, you have enough. So period 1 is not a problem. So period 1, we're good to go. Let's look at period 2. Well, for period 2, we have geography, section B, and we have U.S. history, section A. Now we have 24 students in one and 25 students in the other one. And you can see here that because we have 25 and 27, clearly we have enough books in each set for these two classes. So period 2, check. Let's look at period 3. Be careful here. So period 3 has U.S. history, section B, that's period 3 right here. And then you have world cultures, section A, and period 3 as well. So in one of the classes we have 29 students, and in the other one we have 27. So say the first set here, the one with the most number of books, will satisfy world cultures, section A. But that leaves U.S. history with 29 students, not enough books. So period 3 is a problem. So we mark that here on our little list. For period 4, we see that we have U.S. history, section C, and we have government, section A. So 24 students and 26 students, certainly enough books in both, with the sets that we have, so we don't have a problem. And finally, we have period 6, which is government, section B. 27 students enrolled. Clearly, if we assign this set 1, to that class, we'll have enough books for that class. And so period 6 is also okay. So where do we have an issue with period? For problem 16, it reads, what expression must the center cell of the table below, this one right here, contain so that the sums of each row and each column are equivalent? In other words, if we were to add each of these rows or each of these columns, we would need to find the exact same answer. So let's just add one of the columns or one of the rows. Let's do this one. If we add the first row, negative 4x plus 9x plus 2x, what is that equal to? Well, these are all like terms. They have the same variable x to the same power of 1, even though you don't see it, it's there. And so they're like terms, so we can add them. So essentially, we would need to know how much is negative 4 plus 9 plus 2. Well, negative 4 plus 9 is 5, and 5 plus 2 is 7. So this is equal to 7x. So we need all of the rows and columns to add up to 7x. So that's all that we need. If we look at, say, the second row, we have 7x plus something, and then plus a negative 3x, and we need to make this be equal to 7x. All right, so a couple of things we would need to know here. How do you simplify adding a negative term? Well, when you add a negative term, you're really subtracting. So we can simplify this to 7x plus blank minus 3x. And again, we still need this to be equal to 7x, which we found earlier, right here. Okay, so what term do we plug in here so that the x's end up being equal to 7? Well, let's see. So far I have 7 x's here. I'm going to take away 3 x's, so 7x minus 3x is 4x. I can make a note here. And I need the answer to be equal to 7x by adding or subtracting. So clearly, if I add 3x, I'll get the 7x that I need. So the answer is choice G, 3x.